Yes, I think this is recording. Hello, Miss Crans here. Today we're looking at multiplying and dividing with indices. Now, that's a long way of saying, if I had, for example, x to the 3, why is that not letting me write? I've got to plug in my pen. We live in the future. If I had, for example, x to the 3 times x to the 4, what would it come out with? Because lately we've been doing things like, 3x times 4, well, that's 12x. Or if I had 3x times 4x, that became 12x squared. Why though? Today we're going to look at that a bit more. So in your books, I'd like you to write essentially everything I write and the headings I write as well. So we're going to roll up our books. As usual, line down the side, line across the top. We're going to give it the heading. Well, today's date is for you guys, it'll be the 1st of the 4th, 2020, multiplying and dividing using index laws. That's our heading. So the first kind of subheading we're going to have is multiplying. So when we're multiplying, I'm meaning things like x to the 3 times x to the 4. Notice how I do my curly x's there. I'd like you to start doing curly x's. It's really confusing when you have like x to the 3 times x to the 4 times x. You can see that's confusing already. We don't need that extra confusion in our lives. Now, I'm going to show you the long way to do it. And technically, you could live your whole life doing it this long way. No. Then I'm going to tell you the short way to do it. So, x to the 3, well, that's the same as x times x times x. It's not x plus x plus x. That's 3x. This is x times x times x. That's my x to the 3. If you have different coloured highlighters, I would like you to do one colour over these x's. If you don't have highlighters at all, that's fine. And then that's times by x to the 4. And x to the 4 is x times x, you guessed it, times x times x. Get out your second different colour highlighter. Let me see if green works. Yeah, that looks like different colour. Sometimes they look really similar on the screen. Now, how many x's do I actually have there? 1, 2, 3, 4, 5, 6, 7. So that equals x to the 7, because it's times itself 7 times. It's x times x times x times x times x times x times x. X to the 7. Let's try another example. If I had, for example, I can do this with numbers as well. Let's do that. Oh, sorry about that. Don't often see that. So if I had 5 to the 3 times 5 to the 7 times 5 squared, well, that's 5 to the 3 is 5 times 5 times 5. And then I've got my 5 to the 7, 5 times 5 times 5 times 5 times 5 times 5 times 5. And then I've got my 5 squared times 5 times 5. And that would come out as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5 to the 12. Has anyone guessed the pattern yet? The pattern is, well, what is 3 plus 7 plus 2? It's 12. Did that work for the one above? What's 3 plus 4? 7. So we don't have to write it all out. We can add the indices, so the little numbers, the indices, every time. And we're going to write that, like you're social distancing from me. We're going to write that in a generic form like this. X to the m, so that m is just any number like 1, 2, 3, 4, 5, 6, 7, 8, times x to the n, so that's just another generic number, it could be the same number, equals x to the m plus n. And that's the index law for multiplication. I would like you to highlight that in any way you can. So when we're multiplying indices with the same base, that's really important. Like we can't do this x to the 3 times y to the 4. We can't say, well, that's xy to the 7. It doesn't work like that. We can't put them together like that. We just have to write x3, y4. With the same base, we add the indices. So the indices are the powers, the little numbers. So for example, if I had 7 squared times 7 to the 4 times 7 to the 3, then that equals, well, it's 2 plus 4 plus 3, 2 plus 4 plus 3 equals 7 to the 9. I hope I've added that correctly. That would be embarrassing if I had not. I would like you to pause now and write these notes into your book and then return to keep going with dividing. So are we ready to do dividing? Have you paused me? Pause me! Pause! Pause! I'm going to assume you've paused me and written these notes. You need to write these notes. I'm going to make you write these notes. Okay, I'm now going to scroll down and keep my, I didn't bother ruling up my page. I can't do straight lines. I have to rely on the app to help me. Okay, we're going to set it up really similarly. We're going to have dividing here. We're going to underline it. This time, for example, if I decided to have x, that's about x to the 4 divided by x to the 3. So don't forget with division, it's a fraction. So that's the same as x to the 4 over x to the 3. So that would be the same as, well, x to the 4 is x times x times x times x. X to the 3, x times x times x, yeah? Should have made that one line down. There we go. That's good. And don't forget from your algebra, you know how when we had like 7x y over 3y, we cancelled out the y's because it was top and bottom and it left us with 7x over 3. Remember that? I'm assuming you remember that. You all smashed it. We're going to start cancelling top and bottom. So that. Oh, no, that one has nothing to cancel with. So we just get x on the top and there's nothing left on the bottom, so we write like 1. What is just x? That's x to the 1. There's only one of them. So that's x to the 1 over 1, which is just x. What if I'd had, to keep it interesting, 5 to the 7 divided by 5 to the 3? Well, 5 to the 7 is 5 times 5 times 5 times 5 times 5 times 5 times 5. And that's over 5 to the 3, which is 5 times 5 times 5. Cancel out anything that appears top and bottom. You can only cancel out 1 to 1, by the way. You can't cancel out 2 of them on the top and 1 of them on the bottom. We're left with 5 times 5 times 5 times 5, which is 5 to the 4 over 1, which is just 5 to the 4. Have you noticed the pattern yet? I'm going to try one more. No, that's it. I'm going to leave it there. The pattern. What do you do with 4 and 3 to end up with 1? You subtract. What do you do with 7 and 3 to end up with 4? You subtract. So if you're dividing things with the same base, so it's 5 to 7, 5 to the 3, x to 4, x to the 3, you're dividing, you subtract the indices, which then gives us the general rule. X to the m, so this is anything to the anything, divided by x to the n, so the same thing to something else, equals x to the m minus n. And I would like you to highlight that in any way you can and do a box. We're going to give it the same kind of explanation. Gosh, I'd better finish soon. I'm almost out of my page. This time though, we're not multiplying, we're dividing. And we subtract the indices. So for example, if I had 6 to the 20, I'm not writing that out 20 times. I'm going to use a shortcut. Divided by 6 to the 5, then that's 6 to the 20 minus 5, which is 15. This can come out as a negative number. It probably won't in this exercise, but if it's negative, we're going to explain what that actually means later. But it's fine with a negative number. That's multiplying and dividing indices. I would like you to pause that and continue writing out this half of the page. And then this is the end of the video. So pause. Okay, pause. I'm going to be ending in 5, 4, 3, 2, 1. So this is your chance to pause. 4, 3, 2, 1. Thank you very much. It was very nice working with you.